Welcome back. Today we're going to be doing Chapter 8, Lesson 7. We will be solving one-step inequalities. You need to have your workbook out and open to page 635. The pages we're going to cover are 635 through 638. You also need a pencil, and you have to listen to everything that I'm saying because I might not necessarily be writing things down that I will be looking for in class. So the first thing we're going to do is we're going to talk about two main things that we're going to be learning in this section. They are going to be, we're going to learn how to solve one-step inequalities by adding, subtracting, multiplying, and dividing. And we're also going to be graphing the solutions of an inequality on a number line. Next, I would like for you to look at the real world link. The graph shows the number of home runs that the top hitters on the baseball team hit last season. What I would like for you to do is go ahead and look at the table that is listed right here that I just put a bubble around, and I want you to fill in the correct numbers that go along with what is being represented by each question that is being asked. So go ahead and pause the video, and when you come back, we will go through all three examples. Alright, so as you can see, I went ahead and filled in the numbers according to the way the problems were set up for the greater than or less than symbols. If you have a question as to how or why the numbers are set up in the order that they are, you might want to put a little note over in this area and say, ask the teacher about this. Alright, so first thing we're going to do is we're going to review on how to use addition and subtraction properties to solve inequalities. Now the good thing about inequalities is they are just like equations, except the difference is there's no equal sign. Instead you will have an inequality symbol. Remember, those symbols are less than, greater than, less than or equal to, or greater than or equal to. So looking at our first example, it says solve x plus 7 is greater than or equal to 10. So what you're going to be doing, and I want you to go ahead and recopy this over in the work zone because we have all this area there to use up. So the first thing you're going to do is you're going to start with writing the inequality all over again. Just as we did with equations, I want you to draw a line to separate the two sides of your inequality. So the rules are going to be the same. Our goal is to isolate our variable, so we have to get x all by itself, so that means we have to get rid of the plus 7 on the left side of this inequality. So we do this exactly the same way we did with equations. We're going to use the subtraction property. So we're going to minus 7 on that side and minus 7 on that side. Notice that I wrote it on both sides because what you do to one side, you must do to the other. So these guys over here get canceled out. My x is now by itself. I'm going to bring down my inequality symbol, which is greater than or equal to, and then I'm going to complete the 10 minus 7, and I get 3. So when you're done solving the inequality, what you have to do is you have to graph it each time. Now the book most of the time will give you a number line, but sometimes they won't. So when they don't, and for today's purposes, I want you to go ahead and draw a number line just like I did. We don't have to list all the numbers from 0 to 100. That's just going to take a lot more time that you don't need. What I want to focus on is that 3. I'm going to put the 3 on my number line. We know that all the numbers that come after the 3 are going to be greater than 3, such as 4, 5, 6, and so forth. And the numbers before 3 are going to be smaller than 3, such as 2, 1, 0, and so forth. Now this inequality symbol is greater than or equal to. So that means the type of circle that I'm going to have on my number line is going to be a closed circle. So notice here that I'm shading it in. And the reason why it's a closed circle is because of the fact that my inequality symbol says greater than or equal to. It's that equal to part that tells me that x could actually be 3, but x is also or can also be any number bigger than 3. So your graph is going to look like this. So take example 2. We have x minus 3 is less than 9. If I follow the same procedure as above, I'm going to go ahead and separate my two sides. I need to isolate my variable x, and along with x is a minus 3. So the inverse operation of minus 3 is for you to add 3 to both sides. So that now we're using the addition property. These 3's cancel out. My x gets brought down. I'm going to bring down my inequality symbol. 9 plus 3 gives me 12. So your answer is x is less than 12. When you graph, you're going to draw a basic number line. with a 12 right in the middle. Now, because it's simply a less than sign, it means we're going to have an open circle at the 12, and I'm going to shade in the direction of this arrow, which is everything to the left. What my solution is telling me is that the answer for x cannot be 12, but it can be any number smaller than 12. Go ahead and try examples A and B and pause the video now. When you come back, we're going to go and work through the solutions as well as graphing them, and I would like for you to graph them over in the graphs that they gave you. All right, so to check your solutions, if you look here, I found in example A that n was less than or equal to 3. So you can see on my number line, I have a closed circle at the 3, and everything to the left of it is shaded. What that means is n can actually be the number 3, but it also can be any number smaller than 3. If you look at example B, I found that y is greater than 12, so I have an open circle at the 12, and then everything to the right of it is shaded in. What that's telling me is y cannot equal 12, but it equals any number that is greater than 12. So the next thing we're going to do is we're going to be using the multiplication and division properties to solve inequalities. Just like with addition and subtraction, the steps that you're going to be taking to solve this are going to be identical to those that we learned when we were solving equations, but the difference is you have an inequality symbol. That truly is the only difference. All right, so look at example number 3. On this one here, we have 5x is less than or equal to 45. So just like we did before, what we're going to end up doing is we're going to separate our two sides. Now, I noticed since then that a lot of you are still not showing the proper algebraic steps as to how to divide. When we're dividing in an algebra problem, you show that by making your numbers look like fractions. So what you're going to do is you're going to divide by 5 by underlining it and putting a 5 underneath it. And then on the other side, you have a 45, so we're going to underline that and put a 5 underneath that. What this reads as is 5x divided by 5 is less than or equal to 45 divided by 5. So these 5's over here cancel out because they equal a 1. Bring down your x along with your inequality symbol. And then over on the right side, you have 45 divided by 5, which gives you a 9. And just like before, when you're graphing these on a number line, okay, this part is not any different. You're going to have a closed circle at the 9 because it's telling us that x could be equal to 9, but it also is saying that x is any number smaller than 9 as well. Example 4 reads x divided by 8 is greater than 3. So the way that you would go about showing these is, remember, the inverse operation of divide is to multiply. So you're going to show me a multiplication dot right next to the x divided by 8, like I showed you there, and you're going to put an 8 on this side, multiplication dot, 8 on the other side. Notice that I did not use the multiplication symbol x. You cannot introduce new variables or additional variables when you're dealing with algebra, or they will be completely wrong. To finish this guy out, those guys cancel out. You have x is greater than 24 because 3 times 8 gives you 24. When you graph this, once again, a basic number line with the number 24 there, because it's simply a greater than symbol, it's going to be an open circle and everything to the right gets shaded in. So this is telling you that x can equal any number larger than 24, but it cannot be 24. Go ahead and work on examples C and D. I want you to show me all the proper algebraic terms along with graphing it on the number lines that are provided for you. So you can see that I worked out examples C and D. What I want you guys to do is go ahead and pause your video again, but before you do, double check when you pause that you have your solutions worked out exactly the way they are, because your algebraic steps do have to look like this. And if you pay attention to the graphs, each graph is representing the inequality that you just got done solving. Now on to our last example. This is our word problem. It says, Laverne is making bags of party favors for each of the 7 friends attending her birthday party. She does not want to spend more than $42 on the party favors. Write and solve an inequality to find the maximum cost for each party favor bag. So they started working this out for you guys. What we're going to do is the book has us using the variable C to represent the cost for each bag of party favors. So we're going to go ahead and use C as our variable on this one. If you go back and look into the word problem, it tells us that she's got 7 friends. Oh, let me change the color of that. It tells us that she's got 7 friends attending her birthday party. So we know that the 7 friends and the cost of each party favor, which is why we have the 7 times C, cannot be, the maximum cost she wants it to be is $42. Now here's the trick one. A lot of people see the word maximum, which kind of makes it think as more, and a lot of people automatically want to put that greater than or equal to symbol on this one, but what that's saying is she does not want her party favors to cost anything more than $42, which means this side over here, the 7C side, has to be less than the $42, but it could also equal the $42 as well. So your inequality statement is going to be 7C is less than or equal to 42. Now, if you look over in the work zone area where it says words to symbols, they did remind you here that at most translates to less than or equal to, while the at least translates to greater than or equal to. So from here, we would divide both sides by 7, divide by 7. These 7's cancel out, giving us our answer of C is less than or equal to 6. So what that's telling us is Laverne can spend no more than $6 per party favor if she wants to keep to her budget of spending no more than $42 total. So what you're going to do next is I would like for you guys to complete the guided practice, which is located on page 640. Nope, I'm sorry, wrong page, which is located on page 638. I want to see that you've worked out these problems using the proper algebraic steps. Even though looking at them, I know you can solve them in your head. Remember, I don't want head work. So you have to show me that you've worked out these equations. If you cannot find room on your paper, I'm sorry, I said equations, inequalities. If you can't find room to show me the proper algebraic steps to solving these inequalities, then you can go ahead and complete them on a separate sheet of paper. We'll see you guys back in class.